Welcome. What an honor to kick this off. My colleague Pan Chen is at the table here. We're the reps from Javi here, and as John just mentioned, we're honored to be sponsors for this user conference. Unfortunately, our counterpart at McDonald's, Mike Kramer, was not able to attend. He's a last-second cancellation here, but we'd really like to tell a joint story of a partnership and a business success story for a really challenging promotion that reached into 14,000 restaurants in a very real and challenging way. And I hope you learned a lot through my talk, but if there's one takeaway that I would hold on to if I were you, it would be this. We live in a really exciting time for simulation, do we not? Simulation has been around for 40, 50 plus years, but it doesn't really look the same, does it? There are things like Apache Spark out there that everyone's all of a sudden using. We've got predictive analytics, and I see those dovetailing into simulation, and it makes simulation a more exciting, powerful, useful platform for all of us. So with that, I'd like to, I'll just talk real briefly about Javi, a little bit about who we are. You'll learn a little bit more at the breakfast tomorrow. We are a globally based, privately held company. Had anyone heard of Javi before this morning? Okay, 1, 2, 3, 4. It's actually more than my models predicted. We are probably the largest, least heard of $5 billion global company. Just kind of obscure, and there's a good reason for that. We grew up as sort of the silent partners, supply chain and packaging partners to McDonald's way back in the day. Ray Kroc and our founders partnered together in a distribution and packaging service. So today we do quite a bit of supply chain management. We do packaging services under the supply chain analytics. We have an analytics practice. That's where I reside. We won't go too much more into this. You'll learn a little bit more tomorrow, as I mentioned. Let's talk about McDonald's, though. Normally, if I'm going to be talking about an innovative Fortune 500 company, what are the first ones that come to mind? Apple, Google, Facebook. But I'd like to argue that McDonald's is actually quite innovative in their space. You may not see the same pace of innovation, but they've actually been a market leader in quick service restaurants. So you think back to Happy Meal. It seems like every restaurant you walk into now, you can get a toy for your kids. A lot of that was due to the pioneering of McDonald's. In the early 2000s, they introduced this notion of having a almost full service coffee substation within your restaurant. That was pretty new at the time. The focus on value menu. And then today we'll talk quite a bit about a little thing called all-day breakfast. That was launched about this time last year, actually. It was the #1 most requested customer feedback. They said, you know what, I like what you guys are doing, but I really want to be able to have breakfast whenever I want it. And they said, okay, let's go for it, let's try it. And that was a really challenging problem. We'll talk about that in a little bit. Through the years, McDonald's has also grown tremendously, but also spurred a lot of growth in the restaurant and quick service industry. And we like to think it's no small coincidence that Javi has been a partner since pretty much day one in that journey. So let's think through some of the complexities facing McDonald's or another chain of comparable size when you want to make one of these innovations, right? What about something as simple as a new shake flavor? That's given the fact that there are 14,000 stores and the supply chain underpinnings to support that, that is not a small undertaking, right? So I'll give you a concrete example. A few years ago, you may remember a promotion called Mighty Wings. Did anyone try that, by the way? They're chicken wings at McDonald's. And you think, okay, that's a pretty standard product. It actually took 12 months lead time to work with the chicken suppliers just to ensure that there are enough chicken wings in the United States to be able to run this promotion. So, hey, we'd like to run this promotion, let's plan it. Oh, you're gonna have to wait a year, probably a year and a half to do it. So that's just one anecdote. Another example is with the launch of all-day breakfast last year. What do you think the most needed ingredient was there? Bacon, good guess. Saw some on the table over there. Eggs. Just about every sandwich has an egg in it. Unfortunate timing because there was an avian flu outbreak last year. So your supplier capacity goes to a pittance of what it was, right? So these are just some of the challenges. On top of that, you've got, along with the scale, you've got regional preferences. For example, the Mighty Wings did very well in some regions and not so well in others. Uncertainty, the Mighty Wings was a brand new product. It's very uncertain demand, difficult to forecast. Okay, so let's forget promotions. What if if McDonald's wants to introduce a whole new platform or a very fundamental change to its business, and every sufficiently large company goes through this. I think I saw that Walmart is in attendance here, and whenever you want to bring a system-wide change to your company, that requires so much lead time, so much planning, decision-making, all that. And so just to give you a concrete example, when McDonald's introduced McCafe line in 2001, that was a whole new foray into a business that we weren't sure if it was going to pay off or not, right? One of the problems with that is you're purchasing very expensive equipment. You have a lot of regional variation in your demand. So some store operators were ecstatic about that, others not as much. They weren't sure they were going to get the return on their investment. And so we'll take a dive down that path in a little bit and see what do we recommend for getting an optimal return on some of those capital expenditures like equipment. Additionally, I should note the complexity of the stores. There's 14,000 of them. They actually refer to them internally as snowflakes because each one is a little bit different from the next. They might have the same footprint, and actually a lot of them do not have the same footprint, but they have different equipment, they have different demand patterns, regional preferences. So it makes the work of modelers like you and I actually pretty difficult. So either you can try to simulate the whole universe, or you have to sample and cluster intelligently. Okay, I've talked about a lot of the challenges and problems, right? Well, this is where we come in. And Javi provides a lot of planning and forecasting solutions. That's the bedrock of our supply chain management offerings, as well as supply chain and network design. So you got to be able to contain your costs in your supply chain, and we offer services around that. We also do quite a bit of marketing and promotional analytics. And these all feed, and you'll see in a second, they fed into the simulation studies that we do. You may not necessarily agree that you need all of these, but I can assure you they will help enhance the quality, the results, and the savings of your simulation models. Okay, we at Javi believe that it's not enough just to have the software, such as an AnyLogic or a Tableau. It's not enough just to have the right people. That's challenging too, right? Getting good analysts in the door, getting good modelers. But it requires a disciplined framework as well. So I'll just walk you through the framework that we use. This is applicable to simulation, but it's also, think more broadly. Think about any data modeling and analytics exercise that you could undertake. So this is the process that we approach problem solving with. So you start with the hypothesis. So it might be something as we'll see in a second, like I think that introducing this new type of grill is going to cut my wait times down by 30%. The next is data validation. Do we even have the data? What does the completeness of it look like? Then we can actually run our models. And we can run, in this case, simulation models, get our results, iterate on scenarios. And unfortunately, this is where a lot of people stop. And we think this is, you want to draw that arrow, don't you? You want to draw that green arrow around to the front. But I've seen a lot of cases where that just does not go well, right? What do you think the intermediate step is? What's missing here? Verification, I love it, yes. Business validation is what I'm calling it here. So this is where you take that model and you bring it back to your client, maybe it's an interim update, and you say, what do you think? Does this pass the sniff test? They'll say, oh, no, you can't even fit that piece of equipment. You can't fit that new grill in half of the stores. Okay, back to the drawing board. So we think of this as an iterative process. So we may have to go back, refine our hypothesis, or scrap it all together, come up with a new one, right? So this is the mindset we use to approach this problem and really all our analytics challenges at Javi. Okay, let's talk about the case study. Let's actually get into the simulation work that we did for our partners at McDonald's. About a year ago, they launched all-day breakfast, as I mentioned. Overcame a lot of challenges. I mean, a lot of these kitchens have been around for decades, and they just weren't built to handle both breakfast and lunchtime demand, right? It was a pure cutover. So you stop this process and you start the other one. Additionally, some places, like you could imagine a college campus, all-day breakfast is a very hot commodity that there was a high demand for it. But other places, you might not get so much, right? So where do you roll it out? Do you selectively roll it out? There's regional differences as well. In the South, you can imagine probably in Nashville, people prefer their biscuits for breakfast as the preferred, not so much the Egg McMuffin, but they want the biscuit. So they had to overcome these challenges, and they did, and it was really a smashing success. They pull it off, and there's some public figures out there that it boosted same-store sales as much as 3 or 4%, which is really big. So immediately, of course, you lasso yourself to one good thing, and you say, okay, how can we do this again? Can we do it again next year? And that's immediately where they went to, and they said, okay, this is great, but let's expand it. You could get a very limited scope of breakfast items last year when we launched. Let's try to offer all the breakfast sandwiches. So immediately you're introducing more complexity, more items you have to have stocked and cooked all day. There's competition for the grill space. So there's cooking bacon, Canadian bacon, eggs, sausage, burgers, all on the same surface. So you got some logistical challenges there. And on top of that, they said, okay, it's good. Let's go put it in a test market. But what they found after running it in a few dozen stores was, boy, we better go do some additional work, because they were coming back with a lot more questions than answers. So this is where they came to Javi, and collectively we said, you know what, let's simulate this. Let's simulate the kitchens and see what sort of equipment and what sort of labor we can toggle to solve this problem. So what sort of equipment investments do we need to solve this problem, and correspondingly labor, and then kind of fine-tuning the balance between those as well. So this is a diagram of a typical McDonald's kitchen, and I like to think of this as actually a small production facility or a manufacturing plant, right? We have deliveries of raw materials, we have customer fulfillment metrics we have to make on the other end. We've got a production line right down the middle, and we've got work in progress inventory, workers, all that. So it's not really all that dissimilar from a factory, and we get some of the same challenges and complexities. So this is, I'll walk you through this. This is diagrammatically sort of the decision variables and parameters that were in play for our models. Regrettably, we cannot pull up the model because it's a proprietary McDonald's model. The decision variables here are primarily going to be equipment and labor. So we tune those. We can actually drag and drop various pieces of equipment in, define the capacities, the layout, and just to give you a sense for how big this model is, we had about 50 parameters, 6 data tables, so you can start seeing just how many millions of permutations we have to deal with here. And as you all know, that can be somewhat daunting, right? Just the sheer number of permutations, where do you even start? In addition, we had to keep our customers satisfied, so we kept track of things like what's the average wait time, how fresh, how many seconds off of the grill is my average burger, how much waste am I producing. So we had to keep those in check, and those were really kind of our objectives. So with all those permutations and possibilities, where do you even start? Well, one of the advantages of working with a company as large as McDonald's is they actually have their own physical test kitchens that are built out. They've got about 3 of them. And so what we were able to do was we were invited into these test kitchens, and we ran some baseline scenarios, and we're able to calibrate the model to those baseline scenarios to make sure that things were lining up. So we checked things like making sure the inventory levels were the same in the real world and in our model, as well making sure that those customer service metrics we were talking about, we got to make sure those are key. We've got to make sure those are very similar. And so we were actually in the test kitchens for about 4 days running some scenarios that we'd recommended. So try this piece of equipment, don't try that one. And one nice thing about the test kitchens is it really helps with the business validation, right? If your model comes up with a wacky configuration that doesn't fit in a physical test kitchen, it's not gonna fly, right? So that was a luxury, kind of a unique luxury that we had in this study. The only problem with physical testing is it's expensive, right? Almost a week's worth of testing was a couple tens of thousands of dollars. So and truthfully, that's why we all have jobs in the room, is it not? You can't build out everything. We can do things with AnyLogic so much faster, so many more iterations and scenarios than can be done in the physical world, right? That's why we have jobs. So at the end of the study, what we were able to provide was we were able to recommend additional scenarios that they had not even conceived of with their initial physical testing. Through that, we were also able to identify some savings in equipment costs, so like huge CapEx savings. So when you take $1,000 CapEx savings and you multiply that by 14,000, that becomes a big number, right? And we're excited because while we've dabbled mostly in the kitchen and the drive-through. We think there's huge opportunity for use of simulation and AnyLogic specifically within a restaurant, right? You have, there's some aspects of pedestrian flow modeling in the front, right? I actually learned the tiles, look in next time you go to a Wendy's or McDonald's, anything, the tiles will be different colors and different densities based on where pedestrians walk. I didn't know that. There's more durable tiles in the queue. There are also, of course, opportunities for inventory modeling at the store level as well as DCs. We at Javi do some work in menu analysis. If you run all-day breakfast, what's the impact to the rest of your items? Are you gonna start losing Big Mac sales all of a sudden? So we do halo and cannibalization analysis. That's also well suited for simulation. And then with the introduction of AnyLogistics, we believe that this is really exciting because now you can put that restaurant model in the context of your supply chain. You can solve for things like delivery and routing optimization, right? So that's a really exciting new frontier as well. So I really believe that, again, we're living in exciting times for simulation. We've got a good job. We're starting to see a lot more data, even in the restaurant industry. We've got video data now, we've got sensor data on machines, and on top of that, we're also seeing a lot of customer-specific preferences, right? You log into Amazon and it's tailored exactly to you. Most quick service restaurants now have an app and they send offers targeted for you, right? So what does that mean? What implications does that have for us? There's more data to deal with. There's more models to be run because they're tailored to specific consumers or even segments. So we've got a lot of work to do. But I'm excited to see these things come together and be used successfully in simulation. And ultimately, it's going to lead to better results for our clients. All right, that's all I have. Any questions?
I just have a question. A lot of the scenarios when you run these models, there's a lot of labor differences between the different scenarios. Do you have, when you did the modeling, did you have any automated routines to be able to balance the labor, or did you do that with manual iterations?
It was, so typically we would run time windows at a time. So we would set with a sort of a starting set of staff positioned in the kitchen, and then run it for, say, 2 hours, maybe like a Saturday morning brunch period where you've got a lot of traffic in the store. So it's more manual, but we've worked with models before that do have sort of a automated configuration of labor.
Hi, so my question is like, how did you account for the different sizes of kitchens? Because each kitchen in different places will have different sizes, and
right.
This would affect a lot of things, right?
So we had, one of the neat features about this model is we were able to go in and rearrange the kitchen layout. So we could take like a CAD drawing as the backdrop and shuffle the equipment. So that allowed us to account for multiple kitchen layouts. And you know, we're not going to be able to capture all of them. Just like with the demand data, you have to make some kind of an 80-20 rule. What are the most important layouts to capture? What's the typical demand cluster look like? And so we went with those. Thank you.